All right, starting with number 1, I think it's a good place to start. So this side of the triangle, we don't know what it is, but we do know this angle is 32 degrees. We do know this side is 17. This is the side we call the hypotenuse. Because this side is next to or adjacent to the 32 degree angle, we call it the adjacent side. And because this side is across from it or opposite, this is the opposite side. We don't care about the opposite side though, because it's given us nothing. We don't care about it at all. We just want to know what is the measure of this side right here. So what do we know about this angle, this side, and this side? Well, if we take x over 17, the adjacent side over the hypotenuse, we know that's something we call the cosine. The cosine of 32 degrees should be equal to x over 17, right? Now, 32 degrees, it has a cosine, right? So let's imagine we have a circle. We're looking at 32 degrees. It's like right there-ish, okay? And there's a point here. Imagine it's the unit circle. That means the radius is 1, so it's all 1s all around. Now this guy right here, it's not completely horizontal. It's not completely vertical, right? It's a little bit horizontal. It's a little bit vertical. It's a little bit more horizontal than vertical. Okay, the horizontal component here, with this radius being 1, the horizontal component would be the cosine, and the vertical would be the sine. So this horizontal component of 32 degrees, that's what we're talking about. How big is that horizontal component? It goes horizontal a little bit, it goes vertical a little bit. What's the horizontal component? It's always the same, no matter how big this circle is. The ratio of the horizontal component to the radius is always the same. Okay, so whatever that is, actually we could look it up real quick. What's the cosine of 32 degrees? Make sure we're in degree mode. Hit enter, 0.848, let's say. So this x over 17, this horizontal over this adjacent, let's call it, over the hypotenuse, should be about equal to 0.848, right? 0.848. But let's not use 0.848 because it's just approximate. Let's leave that part till the end. So this is, just keep in mind, it's about 0.848. Okay, so if I had 0.848 equals x over 17, I'd multiply by 17 on both sides to cancel out the 17. And I'd do 17 times 0.848, or, to be more exact, just use the cosine of 32 degrees. So 17 times the cosine of 32 degrees. Okay, what I have in my calculator is the cosine of 32 degrees. I'll just multiply that by 17. Okay, 14.42. No units to report, so 14.42, that's how long that side x is. All right, you see a triangle here. Here's the angle that we want to find. We know that this length of sidewalk is 200 feet. This length of sidewalk is 120 feet. And so we want to know what the angle here is. Well, this is what you'd call the opposite side. This is what you'd call the adjacent side. So the tangent of theta should be equal to 200 over 120. Okay. To figure out what theta is, we take the inverse tangent of both sides. And theta is equal to the inverse tangent of 200 over 120. And we'll grab our calculator. Inverse tangent of 200 over 120. 59.04 degrees, because we're in degree mode. Use a calculator to find the cosecant of 239. Remember, we found out about the sine, cosine, and tangent. And we found out about the cosecant, the secant, and cotangent. And these are all just the reciprocals of these guys, right? So this is like y over r. That was one fraction that defines the sine. And this is r over y. If instead we call this one adjacent over hypotenuse, then this would be the hypotenuse over the adjacent. Okay, and if this is sine over cosine, that's another way to talk about cosine of theta. And this would be cosine over sine. Okay. And the short story is, if we want to talk about the cosecant, it's the reciprocal of the sine. How do I find the reciprocal of something? I can always take 1 over that thing. Take 1 over the sine of 239, and you have the cosecant of 239. So I take 1 over whatever the sine of 239 is, negative 1.17. That is the cosecant of 239. Convert 215 degrees to radians, so we have 215 degrees, and as with any unit conversion, we're going to convert it by multiplying by an equivalence ratio. Okay, that would be pi to 180. It's the same. Pi radians and 180 degrees are the same, so this is 1. What happens here is we cancel out the units of degrees, and we get whatever 215 over 180 simplifies to times pi, right? 215 pi over 180. Okay. What do these guys have in common? Definitely have a 5 in common. Let's take that out. 215 divided by 5, 43. I'll be able to hear the windiness behind me. 180 divided by 5 is 36. Okay, so 43 pi over 36. That's how many radians is equivalent to 215 degrees. Get an engineer who wants to build a bridge across a river. Of course, they need to know how long this bridge needs to be, so they need to know how wide the river is. So, without crossing the river, she can figure out how wide the river is. She puts a stake right here and measures out 57 yards. Why 57? Who knows? But a nice big distance there helps you to be more accurate. Okay, so she walks up the river north 57 yards, and then she takes this thing called a transit theodolite. Here's what one of those looks like: an old kind, an old style one, and then a more modern one. So they just kind of are able to look through this eyepiece at, say from here, look down at the stake, look downriver at the stake, and then maybe, I've never used it, but I imagine they could just kind of dial some things in, say this is like going to be 0 degrees, and then they turn it and look at the tree, at some point on the tree that's directly across from the stake, and then it'll tell us the angle between those two things. So that's why it says here, she uses this transit theodolite to measure the angle between the path and the tree. Okay, so between here and there is 42 degrees. Okay, so that's the angle between those two things. Now we'll get the I think the better looking theodolite over there on the side. Get some room for our calculations. This angle, this side is the angle or the side that we want to know. Here is the side that we know something about, and this is the opposite side. This would be what we call the adjacent side. So we would use the tangent of 42 degrees. That should be equal to, let's just call this x. X over 57. We'll multiply both sides by 57. And x should be equal to whatever 57 times the tangent of 42 is. So 57 times the tangent of 42. 51.32 is about right. Yards. 51.32 yards. We're going to solve the equation for theta, okay? And then we're going to find a theta that is actually between these two. So just imagine like somebody took the sine of some angle and got negative 0.22, right? So they took the sine of some angle, like, well, it's got a negative sign, so it must be from a negative angle. So like negative 25 degrees. Let's see what that is. Oh, negative 0.42, that's not what they took the sine of. What did they take the sine of? Did they take the sine of negative 10 degrees? Okay, that's not too far off, but it's not quite right. How do we figure out what angle they took the sine of? Okay, well, we take the inverse sine of negative 0.22. That's exactly what the inverse sine is used for. It's to find what angle has that sine. So negative 12.71. Oh, but here's the thing. The angle, it turns out, is somewhere between 180 and 270. Somewhere in here is the angle that they actually took the sine of. And if you think about it, negative, what did they say? Negative 12.71-ish, right? From here to here is negative 12.71 degrees. Well, this angle over here, since the sine is the vertical component of that angle, or of any given angle, then this angle would have the same vertical component of this angle. They have the same sine, okay? So whatever this angle is, it also has a sine of negative 0.22. What is that angle? Well, this is a mirror image of that angle, so this little sliver here must be 12.71 as well. So if we go 180 degrees and 12.71 degrees more, we should be there. So 180 plus 12.71, or we could just insert that previous answer there, be really precise. 167.29. Oh, this is negative. That's not going to work. So let's see. We'll just take this guy here, which is negative, so we'll make it negative. All right, so that's going to make it a positive 12.709 degrees. We'll add that to 180. And there we have it, 192.71. 2.71 degrees. Next. Okay, without using a calculator. For both of these, without using a calculator, as I explained many times, that means that it's an angle that is either labeled on our unit circle or coterminal to an angle that we've labeled. So let's look at negative 150. Negative 150. Right there. Right? Negative 180 would take us to right there. Negative 150 is just 30 degrees shy of that. So negative 150. And that happens to land in the same place as, 210. Just happens to be in the same place as 210. So this is 210 degrees. Okay, so what do we know about that guy? Okay, if we're familiar with our unit circles, which we ought to be, we know that this point here is at negative root 3 over 2 and negative 1/2, the x and y values. And we know that this is the cosine of the angle, this is the sine of the angle. Okay. All right. So, well, 210 degrees is the same as negative 150 degrees. At least it's in the same place, right? It has the same sine and cosine and so on. So the cosine of this angle is negative root 3 over 2, so that's easy. How about negative 150? Well, it's the cotangent, which is the reciprocal of the tangent, of negative 150 degrees. Tangent is sine over cosine, so cotangent is cosine of negative 150 over the sine of negative 150. So take the cosine over the sine. The cosine, negative root 3 over 2 over negative 1/2. Well, negative divided by negative is positive, so it's going to be positive. We're going to multiply by the reciprocal, negative root 3 over 2, or we'll take it to be positive now since it's negative divided by negative, times 2 over 1, 2's cancel, square root of 3. That's what the cotangent of negative 150 is. All right, I just feel like switching colors now. Switch over to orange. 2 full periods of the function y equals 4 cosine x. Okay, from our many practice problems of this, homework problems, homework questions, questions before the test, all that stuff, we should know that this guy right here will affect the amplitude, and nothing else will be any different from a regular cosine. Okay, so it's not flipped over, so it'll start at its maximum of 4, because the amplitude is 4. And it'll go down to its minimum of negative 4. The period is still going to be 2 pi, so when I trace out one full period of this to the right, like this. Then that full period happens in a span of 2 pi, and this would be pi, and this would be pi over 2, and this would be 3 pi over 2. And if we went back to negative 2 pi, we'd show that full cycle again. Back up to the maximum. And there we go. Perfectly lovely graph. Okay. Now, negative 3 cosine of 4x, so this is going to affect the amplitude. Is going to flip over the cosine graph. This guy's going to affect, but not be the period, but it's going to affect the period. How does it affect the period? 2 pi over b is always the new period, so pi over 2, okay? So since it doesn't have any vertical or horizontal shifts, I'm just going to put the axes right there in the middle. Okay, it's got a maximum of 3, a minimum of negative 3, because it's got an amplitude of 3. It's a cosine, which would normally start up here, except for it's flipped over by the negative, so I'm going to start down here. And I'll just, split it into 4, and I'll make this the end of that period, which means I'll be in the middle here, maximum there, middle there, all the way down back to the minimum again. Okay, and so this all the way over to here, the end of the period is at pi over 2. This would be pi over 4. This would be half of that. That'd be pi over 8. This would be 3 pi over 8. And we go back the other direction. Here we go. Split it into 4 pieces. Hit those key points. Okay, negative pi over 2, negative pi over 4, negative pi over 8, and negative 3 pi over 8. Alright, this one's pretty straightforward, since the amplitude is always the absolute value of A there. So that's the amplitude is 3, and the period is always 2 pi over b, the number that you multiply by x, or the parentheses with x in it, which that number is 5, so 2 pi over 5 is the period. Okay, sketching 2 full periods of this guy. So it moves to the right, pi over 4, moves up 3, so I'll give myself some room on the right to shift to the right, and I'll give myself some room up top to shift up. I'll show that shift up of 3 first. I'm going to move my midline up there. Alright, let me show my amplitude of 2 now. So remind myself I'm going to go between a maximum of 5 and a minimum of 1. Alright, a sine wave would normally go like this. Right? Between 0 and 2 pi, but because it's shifted to the right, pi over 4, this shifts to the right, pi over 4, right? This would be pi over 2 right here. So this would be pi over 4. Okay, and normally at pi over 2, we'd be up here at a maximum, but that'll shift over here. So that'll be at 3 pi over 4. Normally we'd hit the middle here at pi, but we'll move to the right to 5 pi over 4. Normally we'd hit a minimum here at 3 pi over 2, but we'll move to the right to 7 pi over 2, and we would hit the end of this period at 2 pi, but we'll move over to 9 pi over 2. Okay. So I'll switch over to blue, and we'll start here, maximum, hit the middle, minimum, middle again. Goes up, and comes to the middle, down to the minimum, and back up here. And then we'll show another period, right? We'll go up to a maximum here. See how I'm going in between each of these marks. And then we hit the middle over there. And if we come back this way and hit a minimum right there, then we have full 2 periods. Okay, this would be negative pi over 4, and this would be, let's see, well, you go from 7 pi over 2 to the right 2 pi, because that's the period. 7 pi over 2 plus 8 pi over 2 is 15 pi over 2. So this would be way over here at 15 pi over 2. That'll do it. Okay, this one. Let's see, we have a tide situation. We got high tide, and then we got low tide. Right? This happens, let's look at a timeline here. This happens at 2:47 a.m. Low tide happens at 9:38 a.m. Okay, this is at a height of 43 meters. This is at a height of 15 meters. So we can find the middle mark. That'll tell us like how high the vertical shift should be. So that'll be helpful. We can look at this as a maximum and a minimum. There we go. It's a little better. And to find a full period, we'll have to find the next maximum. So we'll do that. Let's find this guy right here. So 43 minus 5. We'll divide that by, or not 5, 15. Something disappeared over here. Happens sometimes when I undo stuff. 43 minus 15 is 28. Divide that by 2. That's 14. Let's add that onto 15. That'll give us this guy right here, 29. And from here to here is 14. That'd be the amplitude. Okay, I can start writing this. I know the amplitude is going to be like this. And I'll make it a cosine wave, which starts at the maximum, so positive 14 times the cosine of b times x minus h plus k, right? Well, k is 29. That's where the midline is, right? We talked about that before. You find the midline, you find your vertical shift. Let's see. Shifts to the right some. We can shift that maximum over to 247. But 247, that's a weird thing. I'm going to measure it in minutes. Okay, so I'll take 2 hours, which is 120 minutes, and I'll add 47 minutes. 167 minutes. So 167. We'll put minus 167. That'll shift it to the right. 167 minutes from midnight. Okay. Alright, so 167, that's how many minutes it is. That's what we'll do. We'll enter it rather than a time of 2:47 or 9:38, having it converted over to decimal. Let's just do minutes. Okay. From here to here, that would probably be a helpful thing to know. Okay. Let's see. 9:38. How many minutes is that? That's 9 hours times 60 minutes, plus another 38 minutes. That's 578 minutes. So between those two is 411 minutes. That means from here to here to the next high tide is another 411 minutes, which means from the high tide to the next high tide is 822 minutes. That'd be the period. Okay, and we know that 2 pi over b is equal to the period. The period is 822 minutes. So we'll multiply by b, divide by 822, and b is pi over 411. That's what we can go right there. So we have our function, 4 cosine of pi over 411 times x minus 167 plus 29. And the other question is, when do the next high and low tides occur? Well, 578 minutes plus 411 minutes. So 411 plus 578 at 989 minutes. Figure out what time that is in a second. We see the next high tide and the next low tide happens 411 minutes after that. That's going to be 1400. So I can't really 1400 minutes, right? It's out there somewhere. We don't have enough room to show it. But I don't need to show it. I just need to know when it is. So this is the next high tide. This is the next low tide. And it says when will it happen, like, so what time. So let's just figure out how many hours and minutes 989 minutes is. 989 divided by 60. Let's figure out how many hours. Well, 16 and some hours. okay? Well, 16 times 60, that's 960 minutes. So 989, 960 of that makes 16 hours, and if we take 989 and subtract 960, we find out how many extra minutes we have, 29. So that would put us at 16 hours is 4 o'clock, okay? So that's 4 o'clock and 29 minutes, 4:29. Do the same thing with 1400. 1400 divided into segments of 60 minutes gives us 23 hours. 23 times 60 is 1380, so we take 1400 minus 1380, 20 minutes. So 23 hours would be 11 o'clock and 20 minutes. So 11:20. So at 4:29 we see the next high tide. At 11:20 we see the next low tide. And the last one, each of these marks is worth pi over 4, which means that pi over 4, pi over 2, 3 pi over 4, this is pi. This would be negative pi. We can see that that is one full period, so the period is equal to pi. We know 2 pi over b equals the period. Solve for b, we get b is 2. Okay, I can see there's an amplitude change and a vertical shift, but it doesn't look like there's a horizontal shift, so we don't have to do anything there. Let's say we do the cosine function. We gotta figure out what's the amplitude. The amplitude is just like half of this, right? And this is 1, 2, 3, 4, 5, 6, 7.5. So we took 7.5 divided by 2. That's 3.75. Right? So from the middle, which looks like it's about here, to there, is 3.75. That's the amplitude. It's a funny number, but we've been doing it for a long time, where we take the maximum minus the minimum and we split the difference to find the amplitude, 3.75. So 3.75 times the cosine of, it's just going to be something times x plus our vertical shift. So let's, well, that something is 2. We already figured that out, 2x, cosine of 2x, plus the vertical shift. Well, this is at 5. We come down 3.75. We'll find the middle at the midline. That'll be our horizontal shift. So 5 minus 3.75 is 1.25. 1.25. And that is our function. And that will do it. I hope that was helpful. If you have any questions, please do ask.